In this lesson, we're going to learn about the rules of differentiation. And the first rule we'll be learning about is the power rule. So, for the power rule, it says that what we have a function of the form f of x equals ax to the power n, then the derivative of this function, which was f prime of x, will be equal to n multiplying a x to the power of n minus what? 1. So if you have a function of this form, then this will be what? The derivative. Okay, so an example of this type of function will be f of x equals 2x to the power 4. So we have this kind of function here, and then we want to find the derivative of this function. That what f prime of x will be equal to what? 4 times what? 2x to the power 4 minus what? 1. And this will be equal to what? 8x to the power what? 3. So in that case, this will be the what? The derivative of what? This function here. Okay, let's look at how to apply this again. Okay, so let's say you have another function f of x to be equal to 6x to the power 3. So applying this rule here, okay, that will be f prime of x, okay, equals what? 3 multiplying what? 6x to the power 3 minus what? 1. And then this will give us what? The derivative of the function to be equal to what? 18 times what? X to the power 3 minus 1, which is what? 2. So this will be what? The derivative of what? This function here. Okay, let's take another example. Okay, so the next example is y equals 2 over 5 multiplying with x to the power of 10. So in this case, the derivative of this function was y prime, which will be equal to what? 10 times 2 over 5 x to the power of 10 minus what? 1. 10 minus what? 1. So this will give us what? Y prime to be equal to what? 5 will go into itself 1 and then go into what? 10 2 times. So that what? 2 times 2 giving us what? 4 x to the power of 10 minus 1. That what? 9. So you have what? The derivative to be what? 4x to the power of 9. Okay. If you don't want to write this as what? Y prime, then you can write this as what? The y over what? The x equals what? 4x to the power of 9. This is also what? Correct. Okay, so now you see that what? For all the questions that we solved, all the powers were positive. Okay, so all the powers were what? Positive integers. So now let's look at how the derivative will be when the function has what? A negative power. Let's look at that also. Okay, so for a function with negative exponents, okay, so that will be of the form f of x, okay, equals a over what? X to the power of m. Okay, I can write this as what? A multiplying what? X to the power what? Minus what? N. So in that case, you see that what the function was has what? A negative exponent. Now let's look at how you are going to apply the power rule to what, to this kind of function. It is the same as what the previous one that we did. So for the derivative of this function, that what f prime of what x, which is equal to what minus m multiplying what a x to the power what minus m minus what 1. So this will be the general formula. Okay, if you want to apply a power rule to what a function that has what a negative power. Okay, so now let's try an example. So the first example I have here is f of x equals 3 over what x 3 over what x squared. Okay, so with this I'm going to write this as what 3x to the power what minus 2. Okay, so from here we can now find the derivative very easily. So therefore the derivative will be what f prime of x to be equal to what minus 2 multiplying what 3x to the power what minus 2 minus what 1. So this will give us what the derivative of the function to be equal to what minus 6 x to the power what minus 3. So that was the derivative of what this function. Okay, let's take another example. So let's say you have a function y equals what 5 over x to the power x to the power 3. Okay, you can write this as what 5x to the power minus 3. So therefore the derivative which is what y prime will be equal to what minus 3 multiply what 5x to the power minus 3 minus what 1. And this will give us what y prime. This will give us y prime to be equal to what minus 15 x to the power minus 4. Okay, and you can write this as what minus 15 divided by what x to the power 4. This is also what correct. So this is how to apply the power rule when you have what a function that has what negative exponent. Okay, so now let's look at how to apply the power rule to function that has what fractional exponents. Now let's look at how to do that also. So let's when you have a function f of x, okay, to be equal to what a dot n nth root of what x to the power n. We can write this as what a multiply what x to the power what x to the power n divided by what n. Okay, so you can write what this function here in this form. Okay, so you see that what when we write it in this form, we can now what find the derivative very easily. So therefore, the derivative will be equal to n over n times a multiplying what x to the power what n divided x to the power what n divided by what n minus what 1. So now let's try some examples for this method also. Okay, so for the first example, I have what f of x to be equal to 3 times what the square root of what x. Okay, and I can write this as what 3 times what f to the power what 1 over 2. So to find the derivative of this will be equal to what 1 over 2 times 3 x to the power what 1 over 2 minus what 1. So this will be equal to 3 over 2 x to the power what minus what half. Okay, so I can write this as 3 over 2 root of what x. Okay, so this will be the derivative of what this function here. Now let's look at the sum and difference rule. So the sum and difference rule. Okay, so for this rule, let's say I have a function f of x, okay, to be equal to what? P of x plus what? G of what? X. Okay, so when I have a function that is made up of what? Two different functions being added up, then the derivative of this function will be f prime of x will be what? The derivative of the first function plus what? The derivative of what? The second function. The same way, if I have a function f of x to be equal to p of x minus what? G of x, then the derivative of this function will be equal to the derivative of the first function minus what? The derivative of the second function. Okay, so let's take an example to help us understand this better. Okay, so the first question I have here is, let's say you have a function y equals 10x to the power 3 plus 2x. Okay, so I'm going to take the 10x to the power 3 to what? P of what? X. And then I'll take 2x to be what? G of what? X. So therefore what? We know that what? The derivative of this function what? Y prime will be equal to what? The first derivative of the first function plus what? The first derivative of what? The second function. Okay, so now let's take the derivative of what? This function here. Okay, so that what? P prime of x will be equal to 3 multiplied with 10 x to the power of 3 minus what? 1. And that will be equal to what? 30. That will be equal to what? 30x to the power of 2. And then that of the second function will be equal to what? 2x to the power of 1 minus what? 1. And this will be what? 2x to the power of 2x to the power of 0. But we know that what? Any number raised to the power 0 is what? 1. So that was 2 times 1. So therefore, g prime of x will be equal to what? 2. So then we'll have to what? Come and add these two derivatives that we got. So therefore, y prime will be equal to what? 30x squared plus 2. So this will be the answer for the derivative of what? This function. Okay, let's take another example. Okay, so the next example is we have the function f of x to be equal to x to the power 4 minus 3x to the power minus 3. Okay, so I'm going to take this to be p of x, and then I'll take this to what? G of what? X. So therefore, derivative of this function will be equal to what? P prime of x minus what? G prime of what? X. So what you have to do is that you are going to find what? P prime and then what? G prime. So P prime of x will be equal to what? The derivative of what? This value here. Okay, and that will what? 4 times what? X to the power 4 minus what? 1. And this will be equal to what? 4x to the power 3. And then for g prime of x also, that will be the derivative of what? What you have here. Okay, so that what? Minus 3 times what? 3x to the power what? 3x to the power what? Minus 3 minus what? 1. So this will be equal to what? Minus 9 x to the power what minus 4. So then we come out subtract g prime of x from what p prime of what x. So therefore we have what the derivative to be equal to 4x to the power 3 minus 9x to the power minus 4. This will give us what 4x to the power 3 plus what 9x to the power minus 4. Okay, so I can write this as what I have here. Okay, I can write this as 4 4x to the power 3 plus 9 over x to the power 4. So this will be the derivative of what this function f of x here. Okay, let's take another example. Okay, so I have the next example here. We have what y to be equal to 4x to the power 5 plus x to the power 2 minus 10x to the power minus 2 minus 3. So we are going to take what the derivative of what this function here. So for us to do this, we are going to take the derivative of what each of the terms separately, then what we add them. So this will be the first term, this will be the what? This will be the second term, this will be the third term, then this will be what? The fourth term. So I'm going to take the derivative of what each of what these terms. So for the first term, okay, derivatives. So for the first term, the derivative which was dy over what the x will be equal to what 5 will be equal to 5 times what 4x to the power 5 minus what 1. And this will be what 20x to the power 4. And then for the second term, you have the derivative to be equal to 2 times x to the power 2 minus what 1. And this will give what 2x to the power 1, which is the same as what 2x. And then for the third term, okay, you have the derivative to be the y over what the x, which will be equal to what minus 2 times 10x to the power minus 2 minus what 1, which will be equal to what minus 20x to the power minus 3. Okay, then we take the derivative of what the fourth term, and this term is a constant. Okay, so the derivative what will be 0. So the y over what the x will be equal to what 0. Okay, so from here we are going to what add all the derivatives. Okay, we are going to add all the derivatives. Now let's look at that. Okay, so you have what y prime. Okay, that will be the derivative of this function to be equal to what 20x to the power 4. Okay, 20x to the power 4, and then plus the derivative of what x to the power 2, which will be what plus what 2x, and then minus the derivative of what 10x to the power minus 2, which will be what minus what 20 minus 20x to the power minus 3, and then plus the derivative of what minus 3. Okay, that was what minus 0. Okay, so doing this, you know at what this negative here, okay, we'll multiply the term in the bracket, so then we have what plus we have what plus 20x to the power minus 3 plus what 0. Okay, so this will be the derivative of what this function y here. Okay, so now let's look at how to take the derivative of what exponential functions. Let's say I have a function y to be e to the power x. Then the derivative of y will be equal to what? E to the power x. And then if I have a function y equals what? E to the power of kx, then the derivative will be k multiplying what? E to the power of kx. Same way, if I have y to be equal to e to the power of f of x, then the derivative of the function y will be equal to what? F prime of x multiplying what? E to the power of f of what? X. Okay, and also if I have the function y to be equal to what? A to the power x, then the derivative will be equal to the natural log of a multiplying what? A to the power of x. So these are the rules that we are going to apply when we want to take what? The derivative of what? Exponential functions. Okay, so from here, okay, you see that what? When we took the derivative of what? Exponent x, we got what? Exponent x. Let's look at why we got that. Okay, so we are going to look at the reason why the derivative of what? Exponent x is the same as what? Exponent x. So to do this, I'll take y to be equal to what? Exponent what? X. Okay. So now what I'll do is that I'll take the natural logarithm of what? Both sides. Okay. So that'll be natural log of what? The natural log of y equals what? The natural log of what? E to the power of x. So when I do this will be equal to what? Natural log of y will be equal to what? X. Okay, this is because the natural log will cancel out what? The exponent. So from here, I'll take what? The derivative of what? Both sides what? With respect to what? To x. So the derivative of natural log of y will be what? 1 over y dy over what? Dx. And this will be equal to what? The derivative of x, which will be what? 1. Okay, so now let's continue. Okay, so from here, okay, you have what? 1 over y dy over dx equals what? 1. So what I do is that I'm going to multiply both sides by what? Y. Okay, I'll multiply both sides by what? Y so that I can get rid of what? This 1 over y here. So I can cancel out this y here. So at the end I have what? Dy over what? Dx equals what? 1 multiplying y, which is what? Y. But from here we know that what? Y equals what? E to the power x. So therefore we will have what? Dy over what? X to be equal to what? E to the power x. That's the reason why when you have a function y to be e to the power x, its derivative will still be e to the power x. Okay, so now let's take an example under this exponential functions also, and then look at how you are going to apply the rules we just learned about. Okay, so I have the first example here. Let's say you have f of x to be equal to e to the power 2x. Okay, so we know that what the derivative of this, okay, from the rules that we learned about, where we have what? Y to the power y equals what? E to the power kx, then the derivative will be k multiply with e to the power of kx. So I'm going to apply this rule to what? To this question here. Okay, So from the question here, you will see that what k equals what 2. Okay, so therefore what f prime of x will be 2 multiply what e to the power what 2x. So this will be the derivative of what this function what f of x here. Okay, let's take another example. Okay, so I have a function f of x to be equal to e to the power x squared plus what 3x. Okay, so this is what I have now. Okay, so let's find what f prime of what x. Okay, which will be the derivative of what the function f of what x. Okay, so to do this, I'm going to consider x to the power 2 plus what 3x to be equal to what u. Okay, so therefore you have what f of x to be e to the power what u. So the derivative would be what u multiply what e to the power what u prime, sorry, multiply what e to the power what u. Okay, so what you have to do here is that you have to what find what u prime here. Okay, so from here u prime will be equal to what 2x plus what 3. So therefore the derivative okay will be equal to u prime, which is what 2x plus 3. Okay, multiply what exponent u, which will what e to the power what x to the power 2 plus what 3x. So therefore f prime of what x will be 2x plus 3 multiply what e to the power x squared plus what 3x. That will be the derivative of what this function. Okay, let's take another example. Okay, so given the function f of x equals e to the power sine of what x. Okay, let's find what the derivative of what this function here. So I'm going to let u to be equal to what sine of what x. So therefore you have what f of x to be equal to e to the power what u. Then f prime of what x will be u prime what u prime multiply what e to the power what u. So now let's find what u prime. So the derivative of sine would what cosine of what x. Okay, the derivative of sine of x would what cosine of x. So therefore you have what f prime of what x to be equal to what cosine of what x multiply what e to the power what sine of what x. So this should be what the derivative of what this function that I have here.